Hello, my name is Joe Vasta, and today we'll be counting poker hands. Here is a deck of playing cards. There are 52 cards here. This set of cards includes 4 suits: hearts, diamonds, spades, and clubs. We could also break these cards down into 13 denominations: ace, 2, 3, yada, 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 10, jack, queen, and king. The ace could count as the lowest denomination or the highest denomination, depending on the hand you're holding. How many 5-card poker hands are there? Well, in poker, you are dealt 5 cards. The order in which you are dealt the 5 cards does not matter. So there are 52 choose 5 poker hands. Here is an example. 52 choose 5. That equals 2,598,960. There are over 2.5 million poker hands. Now, I'm not going over how the combination formula yields that number. Let's start counting poker hands. A royal flush is ace, king, queen, jack, and 10 of the same suit. Well, since the ace counts as the highest denomination, let's rearrange the picture. Okay, let's count the royal flushes. 10 through ace, all hearts. 10 through ace, all diamonds. 10 through ace, all spades. 10 through ace, all clubs. This gives us 4 royal flushes. Let's take a look at straight flushes. A straight flush is 5 cards in sequence of the same suit. The word straight indicates all 5 cards are in a sequence. The word flush indicates all 5 cards have the same suit. I'm going to exclude royal flushes when talking about straight flushes. This is a matter of style, and other people will disagree with me on this. Let's focus on the hearts. We'll count each straight flush. Ace through 5. That's our first one. 2, 3, 4, 5, 6, 7, 8, 9. There are 9 straight flushes that include the hearts. There are 9 straight flushes for diamonds, 9 for spades, and 9 for clubs. This gives us 36 straight flushes. Let's look at 4 of a kind. A 4 of a kind is 4 cards of the same denomination and 1 unmatched card. First, let's select the 4 of a kind, the 4 cards of the same denomination. I have 13 denominations to choose from. So we write 13 choose 1. This is the complicated way of saying 13. If you keep watching this video, it will become apparent why I am using combinations. Let's select the 3s. I need to choose all 4 of those cards. So we write 4 choose 4. This is the complicated way of saying 1. Let's select all 4 of those cards. Now I need to choose the last unmatched card from a different denomination. I only have 12 denominations to choose from. So we write 12 choose 1. Let's select the 10s. I need to choose one of those 4 10s. 4 choose 1 ways. Let's select the 10 of diamonds. There's our 4 of a kind. Using the fundamental counting principle, we multiply those combinations together to get 624. Note that our yellow selection is just one of the 624 4 of a kinds. Let's look at full houses. A full house is 3 cards of one denomination and 2 cards of another denomination. First, let's select the 3 cards of one denomination. I have 13 denominations to choose from. So we write 13 choose 1. Let's select jacks. I need to choose 3 of those 4 cards. So we write 4 choose 3. Let's select 3 of those 4 jacks: hearts, spades, and clubs. I need to choose the last 2 cards from a different denomination. Now I only have 12 denominations to choose from, so we write 12 choose 1. Let's select sevens. I need to choose 2 of those 4 sevens. We write 4 choose 2. 4 choose 2 equals 6. Let's select 2 of those sevens. How about diamonds and spades? There's our full house. Using the fundamental counting principle, we multiply those combinations together, and we get 3,744. Note that our yellow selection is just one of the 3,744 full houses. Let's look at flushes. A flush is 5 cards of the same suit, but not in sequence. First, let's select the suit. This is a little different from the last few problems. I have 4 suits to choose from. So we write 4 choose 1. Let's select spades. I need to choose 5 of those 13 cards. So we write 13 choose 5. Let's select 5 of those 13 cards. How about the 2, the 4, the 5, the 8, and the king? Now we need to be careful. So far our calculation allows for royal flushes. For example, 10, jack, queen, king, ace of the same suit. It also allows for straight flushes. For example, 2, 3, 4, 5, 6 of the same suit. We need to subtract off the 4 royal flushes and the 36 straight flushes. Let's subtract 40 from our answer. Our calculation gives us 5,108 possible flushes. Let's look at straights. A straight is 5 cards in sequence, but not of the same suit. Let's select ace, 2, 3, 4, 5 of different suits. We selected the ace of hearts, but we could have selected any of the 4 aces. We had 4 choices. We had 4 choices for 2s, and 4 choices for 3s, and 4 choices for 4s, and 4 choices for 5s. Using the fundamental counting principle, we multiply those 4s together. So there are 4 to the 5th, or 1,024 ways to select ace, 2, 3, 4, 5. Let's select 2, 3, 4, 5, and 6. Now we have 2 times 4 to the 5th possibilities. Let's keep going. 3 through 7, 4 through 8, 5 through 9, 6 through 10, 7 through jack, 8 through queen, 9 through king, and 10, Jack, Queen, King, Ace. We've counted 10 times 4 to the 5th ways of getting sequences. But this calculation allows for royal flushes and straight flushes. We need to subtract off 4 royal flushes and 36 straight flushes. Let's subtract 40 from our answer. Our calculation gives us 10,200 possible straights. Let's look at 3 of a kinds. A 3 of a kind is 3 cards of the same denomination and 2 unmatched cards. First, let's select the 3 of a kind, the 3 cards of the same denomination. I have 13 denominations to choose from. So we write 13 choose 1. Let's select 5s. I need to choose 3 of those 4 cards. So we write 4 choose 3. Let's select 3 of those 4 cards. How about hearts, diamonds, and clubs? I need to choose the last 2 unmatched cards from different denominations. I only have 12 denominations to choose from, and I must choose 2 denominations. So we write 12 choose 2. Order doesn't matter. We are still using combinations. Let's select the 9s and the queens. I need to choose 1 of those 4 9s. 4 choose 1 ways. Let's select the 9 of hearts. I need to choose 1 of those 4 queens. 4 choose 1 ways. Let's select the queen of spades. There's our 3 of a kind. We multiply those combinations together to get 54,912. Let's look at 2 pair. A 2 pair is 2 cards of one denomination, 2 cards of another denomination, and 1 unmatched card. First, let's select the 2 denominations which will contain our 2 pairs. I have 13 denominations to choose from. So we write 13 choose 2. Order doesn't matter, so we'll consider combinations. Let's select the 4s and the kings. I need to choose 2 of those 4 4s. So we write 4 choose 2. Let's select 2 of those 4s, diamonds and clubs. Now I need to choose 2 of those 4 kings. So we write 4 choose 2. Let's select 2 of those kings, hearts and diamonds. Now I need to choose the last unmatched card from a different denomination. I only have 11 denominations to choose from. So we write 11 choose 1. Let's select 7s. I need to choose 1 of those 4 7s. 4 choose 1 ways. Let's select the 7 of spades. There's our 2 pair. We multiply those combinations together to get 123,552. Let's look at 1 pair. 1 pair is 2 cards of the same denomination and 3 unmatched cards. First, let's select the 2 of a kind, the 2 cards of the same denomination. I have 13 denominations to choose from. We write 13 choose 1 ways. Let's select 8s. I need to choose 2 of those 4 cards. So we write 4 choose 2. Let's select 2 of those 4 cards, diamonds and spades. I need to choose the last 3 unmatched cards from different denominations. I only have 12 denominations to choose from. I must choose 3 denominations. So we write 12 choose 3. Order doesn't matter. We are still using combinations. Let's select aces, threes, and jacks. I need to choose one of those four aces. 4 choose one ways. Let's select the ace of clubs. Now I need to choose one of those 4 threes. 4 choose one ways. Let's select the 3 of spades. And finally, I need to choose one of those 4 jacks. 4 choose one ways. Let's select the jack of hearts. There's our one pair, a pair of 8s. We multiply those combinations together to get 1,098,240. There are over 1 million pairs. Let's look at high card. High card is 5 cards of different denominations, not in sequence and not of the same suit. Sometimes people call this nothing. This is the worst possible hand in poker. High card excludes straights, flushes, and pairs. Here is an example. We'll count these a little differently than the previous problems. Let's list the results of the other poker hands. When you have one of these 9 types, then you have something. When you have high card, then you have nothing. Let's add up the 9 types of poker hands. The sum is 1,296,420. That's how many poker hands are classified as something, or everything but high card. To calculate the number of possibilities for high card, you take the total poker hands and subtract everything but high card. We saw earlier that the total number of poker hands is 52 choose 5. 52 choose 5 was 2,598,960. And we subtract 1,296,420. And we get 1,302,540. That's how many poker hands are classified as nothing, or high card. This table shows the 10 possible poker hands. Royal flush beats anything below it. Straight flush beats anything below it, etc. We'll leave you with the probability of obtaining each poker hand. I just took each number and divided it by 52 choose 5. I went out to 7 decimal places. And if you add all 10 of those probabilities, you end up getting 1. I hope you enjoyed this adventure through the counting of poker hands. If you understood these calculations, then you're doing a better job than I did when I first encountered this material. Also, you can use this math if you're at a dull party and you want to make it wild. Have an excellent day.